In this video, we shall be doing a simple comparison between the four homologous series that we need to study. That is the alkanes, hydrocarbons with single bonds, alkenes, hydrocarbons with carbon-carbon double bond, alcohols, organic molecules with an OH group, and carboxylic acids, organic molecules with a COOH group. The alkanes and alkenes fall into a category of hydrocarbons because they are made up of entirely hydrogen and carbon atoms only. The alcohols and carboxylic acids are not considered hydrocarbons because they have oxygen bonded to them as well. The functional groups. The functional group is an atom or a group of atoms unique to a homologous series of organic compounds that determine the physical and chemical properties of the series. The alkanes have single bonds between its carbon atoms, thus no unique group of atoms, therefore no functional group. The functional group in alkenes is the double bond that exists between a pair of carbon atoms. The alcohols and carboxylic acids have a functional group that is more obvious. The alcohol has an OH group while the carboxylic acids have a COOH group. The carbon-carbon double bond in alkenes gives the alkene molecule its property. The OH group, called the hydroxyl group, gives the alcohol molecule its unique property. The COOH group, called the carboxyl group, gives the acid molecule its unique property. In the case of alkanes, there has to be a carbon-carbon double bond. Such organic molecules which have at least a carbon-carbon double bond are called unsaturated, and that is because more atoms could be added to them. On the other hand, the alkane is made up of entirely single bonds and are called saturated. The carbon-carbon double bond in alkenes, the OH group in alcohol, and the COOH group in carboxylic acids give the molecule to which it is part of a unique chemical and physical property, and that is why we call them the functional group of the respective series. Next, the general formula. Each homologous series has its own general formula, which is then used to derive the members of the series. For alkanes, it is CnH2n plus 2 with n starting from 1. Alkenes, CnH2n with n starting from 2, alcohols, CnH2n plus 1, OH with n starting from 1, and carboxylic acids, CnH2n plus 1, COOH with n starting from 0. For the alcohols and acids, note where the functional group is written in the general formula. That's the OH of the alcohol and that's the COOH of the acid. With the general formulas now known, let's list down the first three members of each homologous series, their molecular formula and their structural formula. The first member of alkane is obtained by substituting n equals 1 into its general formula, giving us the molecular formula CH4. It has one carbon atom and 4 hydrogen atoms. This is called the structural formula, and to help you with the drawing of the structural formula, keep in mind that carbon needs 4 bonds, hydrogen needs 1 bond, and oxygen needs 2 bonds, and that requirement is met over here. For the second member of alkane, n equals 2, and the molecular formula is C2H6. Its structural formula with 2 carbon atoms, single bond between carbon atoms, the rest of the bond requirement should be filled by hydrogen. Remember that carbon needs 4 bonds and hydrogen needs 1 bond, and with that the requirements are met and tallies with the molecular formula. Similarly, for the third member of alkane, n equals 3, and the molecular formula is C3H8. For its structural formula, it has 3 carbon atoms, single bond between carbon atoms, and the rest of the bond requirements should be filled by hydrogen. As for their names, with a single carbon atom, it's called methane, with 2 carbon atoms, ethane, and with 3 carbon atoms, propane. The ending, that is the suffix ane, indicates that it's an alkane. The meth, eth, prop, that is the prefix of their names, indicate carbon number. Meth for 1 carbon atom molecule, eth for 2 carbon atom molecule, prop for a 3 carbon atoms molecule, and bute as in butane for an alkane with 4 carbon atoms per molecule. Next, the alkenes. The first member of alkene is obtained by substituting n equals 2 into its general formula, giving us the molecular formula C2H4. It has 2 carbon atoms, and as per the requirement of this family, this homologous series, it should have at least 1 carbon-carbon double bond. That is why the series does not start with n equals 1. It starts with n equals 2, which is 2 carbon atoms. And in this case, it has to be these 2 with a double bond between them, as they are the only pair of carbon atoms, and the remaining 4 hydrogen atoms are added to fulfill the bond requirement. Carbon needs 4 bonds and hydrogen needs 1. For the second member of alkene, n equals 3, and the molecular formula is C3H6. For its structural formula with 3 carbon atoms, we need to choose which pair will have the double bond between them. It could be the first 2, which then results in this structure, or the second 2, which then results in this structure, and both are the same. Similarly, for the third member of alkene, n equals 4, and the molecular formula is C4H8. For its structural formula, it has 4 carbon atoms. We need to choose which pair will have the double bond between them. It could be the first 2 resulting in this structure, or the second 2 which results in this structure, or it could be the last 2 which could be similar to the first one. As for their names, with the carbon-carbon double bond, the first member is called ethene, with 3 carbon atoms propene and with 4 carbon atoms butene. The ending, that is the suffix ene, indicates that it's an alkene. The alkene series starts with 2 carbon atoms. Therefore, there does not exist a methene. There has to be a carbon-carbon double bond. Thus, a 1 carbon atom alkene does not exist. Next, the alcohols. The first member of the alcohol group is obtained by substituting n equals 1 into its general formula, giving us the molecular formula CH3OH. This organic molecule has one carbon atom, and as per the requirement of this family, this homologous series, it should have an OH group called the hydroxyl group attached to it. And in this case, it has to be bonded to the only available carbon atom, and the remaining 3 hydrogen atoms are added to fulfill the bond requirement. For the second member of alcohols, N equals 2, and the molecular formula is C2H5OH. For its structural formula with 2 carbon atoms, the OH group can be bonded to any of the 2 carbon atoms, and both will give you the same structural formula. Similarly, for the third member of alcohols, N equals 3, and the molecular formula is C3H7OH. For its structural formula with 3 carbon atoms, the OH group can be bonded to any of these 3 carbon atoms. Binding the OH group to the first or the third carbon atom will result in the same structural formula, but if bound to the second carbon atom will result in this one, and its structure is slightly different but is the same compound. As for their names, the alcohol group will end with ol. The first member with 1 carbon atom is called methanol, with 2 carbon atoms ethanol, and with 3 carbon atoms propanol. Ending, that is the suffix ol, indicates that it's an alcohol. Finally, the carboxylic acids. The first member of the carboxylic acid series is obtained by substituting N equals 0 into its general formula, giving us the molecular formula HCOOH. This organic molecule has 1 carbon atom, and as per the requirement of this family, this homologous series, it should have a COOH group called the carboxyl group attached to it. And in this case, it is on its own. It should have 1 carbon atom, and that too is provided by the functional group, and the hydrogen is attached to it. For the second member of carboxylic acids, N equals 1, and the molecular formula is CH3COOH. For its structural formula, it should have 2 carbon atoms. The COOH group contributes to 1 carbon atom, and the rest of the bond requirement is completed with the remaining hydrogen. Similarly, for the third member of carboxylic acids, N equals 2, and the molecular formula is C2H5COOH. For its structural formula with 3 carbon atoms, of which one of them belongs to the COOH group, the remaining hydrogen is bonded to the other carbon atoms. As for their names, the carboxylic acids group end with OIC. The first member with 1 carbon atom is called the methanoic acid, with 2 carbon atoms ethanoic acid, and with 3 carbon atoms propanoic acid. The ending, that is the suffix OIC, oic, indicates that it's a carboxylic acid. And with that, we have a few important points to note. Firstly, the difference between any 2 consecutive members of any series would be a CH2, a mass of 14 units. The difference between ethane and methane is a CH2, between butene and propene a CH2, between propanol and ethanol a CH2, likewise between propanoic acid and ethanoic acid a CH2. Furthering that understanding, the difference between propane and methane would therefore be double that, a C2H4, a mass of 28 units. Secondly, the trends within each group has to be understood. Down the group, the carbon number increases, the size of the molecule increases, therefore the intermolecular forces of attraction increases, therefore the viscosity increases, the flammability decreases, and the boiling point increases. Thirdly, the reactions within the group should be similar. For an example, alkanes undergo substitution reaction. If methane can react with group 7 elements, halogens, then so should the others in the series. However, the reaction would be less reactive due to increasing molecule size.